Welcome to Liquid Assets. I'm your host, Ravi Karani. Liquid Assets is a podcast where we talk about the intersection of business, policy, and technology, all as it looks at water.
We'll continue to innovate for the next 3,000 years. The thing that's probably caught my eye that I've been working on most excitedly for the last kind of 2 or 3 years is this forever chemicals or PFAS. And so I think this by far will be the legacy problem of the next 50 years.
Welcome to another episode of Liquid Assets, where we talk about the intersection of policy, management, and technology, all as it looks at the world of water. Today, we have an amazing guest for you. We have Chris Morrison from Morrison Water.
I'm Chris Morrison. I'm a water treatment consultant. I run Morrison Water and try to help people build sustainable solutions to water treatment problems.
Chris, how are you doing today?
I'm great. Nice to see you, Ravi.
Good to see you too. We were talking earlier about the Burning Man fiasco, by the way. That is absolutely ridiculous of what just happened over there.
Yeah, I think it's also a sign of technology and innovation. What went through two of my sons, as we were just chatting briefly before, we're stuck there, but found a way out. And as I hope everybody does on Burning Man, but I think it shows you the challenges of doing kind of different types of activities around the world and trying to make your rest of your life still coexist. So very difficult.
Let's go ahead and jump into the podcast. I know you started your career at Nalco and Ecolab. I'd love to you're such an interesting guest because you've had such a plethora of experience. You've been through multiple geographies, multiple different places where water has touched with, mining, paper and pulp. Let's just go ahead and kick it off with kind of the beginning of your career. I think it'd be really interesting for the audience to start at the Nalco Ecolab, unless you want to go a step further. But I think Nalco and Ecolab probably is a good starting point.
Yeah, really interesting. I was a biology and engineering major in college, couldn't find a job, working as a bartender, playing baseball part-time down in San Diego. And I happened to find, because my dad kept sending me letters with job opportunities, an opportunity with this company called Nalco, and ended up interviewing and getting a job for them. But I was really hoping to go back to Mexico and keep playing baseball. I had a girlfriend down there, and they were paying me the large sum of $2,000 a month when I started. And I said, if I work for 90 days and stay at my mom and dad's house, I can probably save $5,000. And basically that was 2 years worth of money in Mexico. So that was my original dream. And I tell the story to at least my kids about how on day 89, I got up the courage to go talk to my boss about, I got to leave tomorrow because I'm going to go see my girl and I can't wait. And sorry, I'm leaving my career. I might come back, I might not. And I had this whole concocted story. And as I walked in, he told me that he had a new opportunity for me and that they were giving me a raise to like $2,200 a month. And I had this long career and how excited he was for me. And I just thought that was amazing. And I ended up staying for 37 more years. So it gets kind of funny how things turn out. When I started, I might add, water treatment, when I tried to explain to my friends what I did, they really kind of, their eyes kind of got tight and they said, well, what is that? And I said, well, we help manufacturing plants, which is really what we do, try to use water more efficiently, basically make more product, whatever they're making, from a brewery making beer or a winery making wine, steel plant making steel, make more products, more widgets using less water. And so really it was the early days of water efficiency. And in those days, water was incredibly cheap. And people will still say it's probably still not on full value, but part of it was getting people interested in saving water, being more efficient. And that was really the early part of my career.
And it's actually raised an interesting point. So you guys started off with building a product or a service around water efficiency, but water was, even cheaper than it is today. What was there like a value proposition there? Did you go to customers and they were like, hey, this is a non-problem right now. Do we need to focus on this? How did the customers take that value proposition?
Well, the company was actually started in, I think, 1928 or 1929. Nalco stands for National Illuminate Company, and really was steam locomotive boilers. And a lot of them were blowing up, or would get this heavy laden scale in them. So sodium aluminate was one of the first scale inhibitors that was formed that would reduce the amount of scale. And scale, even a 16th of inch of scale, kind of an eggshell thickness of scale, can impede heat transfer as much as 10 or 15%. So what we were really selling was clean boilers, clean cooling water surfaces. Those are the two major, water saving and energy saving applications that the chemicals and the services that we're doing. We also did wastewater, processed water, softeners, ROs, all those other things over the years. But initially, it was really focused on boiler, cooling water, and process applications.
Interesting. Okay, that totally makes sense because you're focused on asset management and asset protection versus versus reducing the cost of an input being water.
Yeah, it relates great to water. And today the driver a lot is water.
Sure.
Most people have solved the scaling problems by removing a lot of the calcium and magnesium from the water, or figuring other ways to handle kind of the mineral concentration. So those chemicals become less important, and the overall water balance, or the way to improve the feed water or makeup water, really becomes vital.
Yeah, totally makes sense. And so let's kind of jump into what was the day in the life of, Chris post not going to Mexico, living with Nalco. What was the day to day there at, I think it was at the 1980s or so when you were at
Yeah,
Nalco?
1980s. You make me sound very old, Robbie, but I guess I am old. So, it was a fascinating job because the career, and I actually, a friend of a friend just started working for Nalco, and I think it's still a great career because I literally went to canneries. I took care of Del Monte canneries out in the Salinas Valley. I had a large brewery in Northern California, a vegetable oil plant, had a number of industrial steel manufacturing, and eventually got into the refinery business, where you have just really high pressures and huge cooling volumes, all very complicated and laid out. So I think the most interesting thing was every day was different. Every customer was different. Every application was different. It took probably 2 to 3 years to be really fairly decently competent. And then, every year you add a little bit of expertise, and that's really the value of, if you deal with someone that's been a water treater for 20 or 30 years, they've seen a lot of different things and can really optimize your situation from their knowledge. Much like a kind of an eye doctor versus a general doctor. You need someone that's really a specialist to help you optimize your water cycles and energy balance.
Yeah, that totally makes sense. And if we were to, it's so interesting because Nalco does sell into these different industries, like, the canneries, the breweries, the refineries. When you you kind of double click into each of those markets or each of those applications, I think it'd be really interesting for the audience to hear kind of what is a problem that you see as somebody that's from Nalco, that's kind of in depth in these industries, that somebody that's a layperson wouldn't know, right? If we were to just even start with refineries, what's kind of an interesting fact?
Well, I think refineries, it's an incredible process. Okay, so it's a continuous process where they're bringing in oil and they make like 130 different products out of one barrel of oil that comes in. So and it's dynamic. So they don't have a lot of buffer or storage, and so they are very efficient, and they want to make it as low cost as they can, which means they want to make all their heat transfer as efficient as possible. So if you think about the basic refining process, they heat it up to somewhere between 400 and 1,000 degrees Fahrenheit, and then they fraction off different parts of the oil to make a light, gasoline or diesel, jet fuel, and then the heavier crude and lube oils and all the different byproducts that come out. So in that process, they use a lot of steam because that's what they use to heat it up. So they have these huge boilers and power plants. So they want a very efficient plant that they can rely on. So if you have a boiler failure or a tube failure, you got to shut down the plant. They got to shut down the whole refinery or slow it down. So the refineries are really long-term thinkers. They invest in long-term assets and, engineering and chemicals and processes, consultants like us to make sure that they run at the very highest levels of energy, highest levels of availability, repeatability, that their plant's going to be available, and then make sure that they're using the least amount of water, chemicals, and everything else to do that. So it's quite a bit involved process, and these are really smart senior engineers that run all this. So you're not going to pull one over on them. When they ask you a question, so why do you think that's important? You better have the right answer for it, because they'll drill you on the process.
Yeah, yeah. And was the problem similar to what you mentioned earlier of Nalco's initial value proposition of scale management, or is it kind of
Yeah,
different across?
scale and that, it's a safety issue, and it's certainly, before you blow it up, you've got a lot of loss of heat transfer. Even if you don't blow it up, if you got a lot of scale, then you have to clean the boiler or router it down, acid clean it. So we're about prevention in that case of optimizing the water cycles without causing damage and making sure that you can count on the machinery. So the value proposition was a number of things, but again, kind of like the doctor example I used, you have to be a trusted advisor to these people. They have to put their trust in you, and you don't ever want to get them, guy has a heart attack and 2 months later he says, I'm thinking about going and hiking a 100-mile trail. You need a doctor who says, not a good idea. You might make it, but there's 30% chance you're going to die. Don't do that.
Sure.
So you want to tell them you can try different things, but these are the things where I think your limits of exposure are, and to be careful to avoid these particular areas.
Makes sense. And the kind of thing that comes to mind too from a company like Nalco is around the sales process. If you guys are trusted advisors to these larger refineries or breweries, is the sales process kind of mostly a word of mouth, or is there a pretty large sales B2B feet on the ground that go out there? How does that, or do you have any?
Yeah, it's B2B, and you're always looking to expand your business. So basically, I was hired as a sales engineer, but you really become pretty quickly really a water treatment engineer that also sells chemicals. You're only going to get business if you're credible, if you're smart, you're insightful, if you can help your customer, basically do his job better, and that they trust you. And so, if they think you're ripping them off or trying to sell them extra perfume to make it look better or smell better, but it doesn't really do anything, they lose interest in you and you lose business. On the other hand, if you're really good at what you do, project engineer A goes to work at another refinery, immediately calls you up and says, I can't believe what they're doing over here. It's nowhere near the professionalism and the degree of technical competence that you've got. Would you come over here and help me out? And next thing you know, you got a new client. So it's about kind of making sure that you're as good as there is anywhere, and that people do get a reputation, both about the company, but it really comes down to the person that's doing the work and having the conversations with the other.
Yeah. Yeah. And so we've kind of covered your not going to Mexico story to stay at Ecolab Nalco. What happens next? What's the next step?
Yeah, so I did a series of jobs I really wanted to stay in California. I'm a California-based kid, and was looking at a number of jobs in Chicago, and my wife and I were really not interested in Chicago. Nothing bad about Chicago, but if you live in San Francisco, you kind of know that you kind of want to stay here. And we had a couple of kids, and the CEO of Nalco basically came to me and said, we have a great assignment for you. We'd like you to consider moving. And he kept saying to Chicago, and I kept saying, but what finally happened was they had an opportunity open up in the Pacific in Sydney, Australia. And he thought it was a unique fit because I had kind of the management and technical commercial skills pretty well honed in California. And a Californian is a much better fit in Australia than someone from Chicago or New York. So we moved our family. We had 3.5 kids. My wife was pregnant, to Australia, to Sydney, thinking we'd move back to San Francisco in 2 or 3 years. And we just fell in love with the Pacific and the people of Australia. All new sets of problems down there, of which I hadn't seen as many before, but all very similar to, the water treatment problems in South Africa are the same in Australia and the same in San Francisco. So in the end, you just have to get on it and figure out how to start working with people and provide good, sound technical advice, and things turn around.
I want to double click into that a little bit. You said that the water problems are the same from South Africa to Australia to San Francisco. If you were to kind of say three bullet points, right, 3 or 4 bullet points that are the top water issues, what would you say those are that you kind of saw in those?
Excuse me. Well, I think in the 80s and 90s, it certainly was just straight out, energy savings and, kind of best practices, clean heat transfer services, both on the cooling and the wastewater side. And then there's processed water coming in, a new innovation in 91, 92, started these amazing membranes, reverse osmosis, and very slow to take off. And a number of us, including myself, got really enamored by them, and we became proponents of them. Most people just had a sodium zeolite softener to remove the hardness, but these things were much more efficient and would allow you to have much higher cycles of concentration, much less water loss, and much cleaner boiler surfaces or cooling water surfaces. So we became advocates of reverse osmosis early, and we're able to be credible in front of our clients saying, actually, this might save you some money on chemicals. We don't care. We're just here to service you. But most importantly, you're going to get better energy savings and cleaner surfaces. And so we kind of dominated the market with an alternative offering that was a little counterintuitive.
And just for the audience out there, can you explain the difference between sodium zeolite and reverse osmosis, and kind of first of all, what is the difference? And then secondly, what does it actually do for the membrane and the processed water?
Okay, well, most of what we're talking about here is boiler feed water pretreatment. So for power plants, for any steam boiler, usually you soften the water beforehand. So they use something called ion exchange, and that's a sodium zeolite softener. It's a plastic resin bead that you regenerate with salt. Some people have them in their homes. Most industries had them, certainly in the 60s, 70s, and 80s. That was the normal. Soft water was the normal boiler feed water. It transitioned really in the 90s as reverse osmosis became almost as cheap as an RO to be able to do it, but people didn't know how to operate the membranes. The early ones failed. And so it became a transition for us as water treaters to help our customers select the right pretreatment for the right application, and then monitor and make sure that it performed correctly. So the difference is, if you have water in Los Angeles, you might have 200 parts of hardness, 600 or 700 parts of totally dissolved solids or conductivity. And if you put it through a softener, you might come out with 1 part of soft water, 1 part of hardness, we call it. You'd still have 700 or 800 conductivity, and you send that to the boiler with some chemicals and everything would be fine. But you might run blowdown at 10%. So 10% of the steam that you're making is actually being shot down into a tube to keep the cycles from concentrating too much, the minerals from depositing on your heat transfer surfaces. If you use membrane treatments, the water's super clear, so you might only have 0.1 or 0.01 of hardness. So when you put that to the boilers, you need less chemicals because the chemicals are there to keep the hardness in solution. So you save on chemicals, but most importantly, you can take your cycles up to 100 or basically have 1% blowdown. So if you're making 100,000 pounds per hour of steam, instead of blowing down 10,000 pounds and wasting all that heat, you can only blow down 1,000 pounds per hour of steam, and a lot of energy efficiency is derived by increasing the cycles.
Yeah, no, that makes a complete amount of sense. And the two things I kind of hear you say is from your inputs with using a technology like reverse osmosis, back in the day, you guys were pitching less chemicals inputted because the chemicals are there to basically soften the water. But then more importantly, you could decrease a 10% blowdown to 1%. You have a 10x reduction, which would obviously decrease energy as well. And I think, energy and chemical costs are great cost to decrease. Yes. Totally makes sense. So fast forwarding, you kind of were in, South Africa, Australia, San Francisco. What happens next?
So unfortunately left Australia, had a brief stint in Indonesia with my family. So now we have 4 kids and a nanny and a wife. We traveled to Indonesia. Suharto overthrew the government there. So we were there about 4 or 5 months, and all the expats were basically asked to leave. We went back to San Francisco, and it turned out my new assignment, after looking at a number of different things, didn't want to go to Chicago again. We're back in San Francisco after kind of 4 years out of the country. I started up a group within our company called Strategic Accounts. So we were trying to aggregate customers and trying to teach them that if you're, Nestle's and have 50 plants in North America, if we treat them all, we can talk about best practices. We can make up books on all your boilers. We can train all your operators. We can do competency testing. We can do all sorts of things for you. But if we only have 10 of your plants, you give 10 to someone else and 10 to someone else, you have no idea what the costs are going to be. You don't know what the level of technical service you're getting. You want the plant to make the decision in some things. But basically what we did in that role, and that started like in 1998, was trying to convince the customer that they were better off buying it corporate and selecting the flavor at the plant instead of selecting the water treater at the plant and kind of selecting the flavor at the corporate level. So we really tried to build tight relationships. Every larger company, be it Kellogg's or Anheuser-Busch or U.S. Steel or Chevron, has a corporate engineering department, and they're trying to just work on best practices.
Yeah.
And so I went from really having 2 or 3 people to, in less than 5 or 6 years, I had about 25 people around the world that were these strategic account managers, very technically competent, very credible, very successful for kind of 10, 20 years before that they got this role, kind of like me. And we're able to go to corporate customers and talk about, let's work on your overall water budget. Let's work on sustainability. Now water and water savings is starting to play into it in the early 2000s. And so that became a great platform. There's one large, I can't say the name, but microelectronics customer that's out of San Jose that builds little chips inside. And so they really wanted a copy perfect. They wanted a water treatment in all 15 of their fabs all around the world. And they were in many different countries. That was perfect. And they tried in different factories to get a different process, be it their reverse osmosis practice or their cooling water practice, their boiler practice, their air scrubber practice, but they wanted it perfect. They wanted clean surfaces. They wanted an analytical method to test them, to inspect them. And so we started building what we called white papers for them and all their different processes, eventually working up to having a global contract where we took care of all their business and kind of rolled up the water savings. We'd have big annual meetings, kind of a day or two with a retreat. And, how much water do you want to save this year? How much do you want to invest? Where can we go? What are the early pickings projects? What are the more difficult, more expensive ones? And so it really became a fascinating interpersonal relationship with some really thought-provoking people that were really in a position of I don't even call it power. They wanted to make their companies better, and they had to shrewdly decide who they wanted to work with. And obviously we wanted to do that. And then in turn, we gave them a better deal because we don't have to have 50 salespeople out calling on every Nestle plant. We got one contract, one clear guidance. We have to deliver at all 50 plants. You can't just deliver in 49. We always found that our hardest thing was in that weakest, maybe smallest plant that was 48 hours of travel from Boise, Idaho to get to. But, we tried to deliver the same level of service all the way around the globe. And really an interesting business life for me, and just really enjoyed doing that.
What was the inflection point that gave you or the Ecolab team this kind of idea of having the strategic account side? Was it kind of this move of, hey, we're just selling chemicals? Is there a way to kind of take our largest accounts, and instead of having, like you said, 50 sales guys that are knocking on everybody's door, it's really interesting to see what was that inflection point that got you guys to move from before strategic to strategic?
Yeah. First up, in our biggest customers, pulp and paper and oil and gas, they were already doing it. So they Of course, there's only 5 or 6 oil and gas companies. There were only about 10 real big pulp and paper companies. So they were already doing it. And we thought we might be able to do it in, I'm going to call it the medium size accounts. Okay. And the reality was that the customers were a little bit ready to do this, but it was really us going to them and then developing a mutual value proposition. There was something in it for us because we didn't have to go every year and try to win back our contractor. They put it out to bid, and there were all these purchasing agents trying to save everybody money at different times. So it was the assurity of business for us, the renewals and the ongoing relationships. And B, it was what we were really good at, okay, was delivering value. And we hated to see that value destroyed. You go into a big plant, you save them all this money, and then 6 months later, they have a new purchasing manager and they say, yeah, we're putting you all out to bid. Thanks for everything you did, but what's your price going to be this year? And it's kind of like, you can't do that. We just saved you $3 million. You're going to try to save $100,000 on our bill. I mean, it just doesn't make any sense. And so we convinced the customers, I think, and they convinced themselves that it was in their best interest to do it. And, you know, we got many, many large customers. I remember the largest chicken manufacturer in the United States, they had about 12 different water treatment companies treating their 137 different poultry plants. And every year we would lose about 10 and gain 10. We kept somewhere between 18 and 25. At the time, this was early 2000s, they were blowing up about 5 to 10 boilers a year, okay, because of scale problems, because they turn over their reps. And of course, if I just started treating it in January, I'd say, well, it was last year, your guy didn't treat it right, and it's not on me, you know. And so everybody was just pointing different directions. So we found the right person, and we thought about this for a long time. And one of our VPs was really involved in this, Mary Kay Kaufman, and she came up with this whole thing of, I think we should just pitch them that we take it all. But if they have a boiler insurance problem, that we pay for it, which is kind of unheard of in our company. Okay. And she went to the mat on this thing and got the upper levels to approve it. And basically we went back to this company and said, you will never have another boiler insurance problem. They were going to lose their insurance company, which was the other thing that was on the table, because they were having so many potentially safety problems and everything else. And they didn't want that. And so we went back to them with a way, we're going to treat all 137 of your plants. We have a 5-year contract, no cut, as long as we deliver. But every time you have a boiler problem, we pay. And basically, in less than 30 days, we had a 5-year, multi-million-dollar contract, and still treating them today successfully, I might add, 20 years later, as far as I know.
Interesting. It's so interesting to see how a cost center like this insurance issue that you guys were having would then turn into an opportunity by your team to get a much larger, like you said, revenue set for Ecolab Nalco, but also solve a very distinct problem for the buyer, which totally makes sense.
Absolutely.
Huh. Really
yeah,
cool.
and by the way, their costs, I think, doubled. So the line item actually doubled, but their insurance costs, their water costs, their chemical, their overall efficiencies went up. I mean, they had multi-million dollars in savings, but it took somebody on their side of the equation, you know, to say, wait, you're going to charge me double? I go, yeah, but this is what you're going to get out of it. And so it just needs somebody to be able to articulate that to someone and be credible, and then come up with an offer that has a counterbalance that makes sense commercially, technically, for the operation. And in this case, it did.
Yeah, it totally makes sense. So you hopped into strategic accounts. What happened next?
Well, so really just expanded at a very fast rate, and still one of the biggest parts of, I think, Ecolab Nalco. I think our sales at the time, I'm going to say at the turn of the century, 2 decades ago, were about 1% corporate sales and 99% kind of individual guy in Lyon, France, or in Dubai, calling on a plan and helping them out. And I think today it's closer to 40 or 50% are via corporate relationships. So it just goes to show you it does change quite a bit over time. I did that until really we merged Ecolab and Nalco, and I got an opportunity to do a new job. Wasn't sure what it was doing. I was in Switzerland at the time, so I ran our operations in Europe for a while. Very interesting. Same type of water problem, same sort of solution set, but we were doing some good things there. And came back and then really had a passion for helping out in innovation, trying to find new water innovations. Our customers, much like I talked about reverse osmosis in the past, wanted newer things like that. They wanted, ceramic membranes. They wanted new sensors that helped them reduce the amount of labor and analytical. They wanted novel new chemistry so that they didn't have to shut down and inspect. They wanted to run longer. They wanted to eliminate Legionella. They wanted to, basically improve the hygiene and all parts of the water savings. Certainly by 2013, 2014, ESG goals were becoming important, even if that moniker wasn't on them. And so, I the last 5 years of my career, basically, I ran a group called Water Innovations, and we looked at a couple hundred different opportunities, be it probes, be it new technology, new hardware, new software, new sensors, but ways to help our customers make more products, sell or use less water.
Totally makes sense. And that it actually seems like it springboards perfectly to kind of what you're up to now with Morrison Water. I mean, I've seen you're on the board or / investor in multiple different companies. I saw Tails, FredSense. Talk to us a little bit about what kind of the world looks like today for you, and what are you seeing in terms of the technologies you're advising for and kind of who you're working with.
Yeah, I think it's really fascinating. I mean, I did it for our corporation, and then I retired, and really the phone just kept on ringing, and all of them were interesting. Many of them I decided not to do, but the few that I did, I think are really great companies, young entrepreneurs that have a good widget. Okay, so the thing we learned very quickly in Ecolab and R&D is that a good widget doesn't mean anything. You have to have a customer need defined. You have to have a plan of bringing it to the market to get traction and to get in front of the customer. And it's got to be relevant, and it's got to be quickly accepted and adopted if it's going to have any chance of success. So for me, it was to find, okay, were there any of those things out there? And I found a few. And I think what I'm really working on is kind of that product fit, speed to adoption cycle, and trying to get it. Frankly, the average product innovation cycle is at least 8 years. So from a really successful lab widget to a commercial success, and we call commercial success kind of in excess of $5 million a year of revenue, to get from 0 to 5 million, somewhere between only 20 and 30% of the widgets that are successful in the lab actually make it there. And so trying to optimize that is really what I think my skill set is, and what I've been working on all day with a company up in Canada today is just, how do we do this? How do we go faster? How can we get our message out more clearly?
What are you seeing in terms of technologies, or I guess customer problem sets that need to be solved? Like what is the question is kind of twofold. What are the technologies you're working on today, which probably signals your understanding of what customers need? And then secondarily, what hasn't been built yet that you see as problems that the customers are asking for, but doesn't exist in the world?
Well, there's lots of things that haven't been built yet. We'll continue to innovate for the next 3,000 years.
Sure.
I think more efficiency, trying to make plants and processes run better. So any wastewater plant is only at best 30 or 40% efficient. So can you make it more efficient? Can you make less sludge, using less energy to take the solids or the BOD or the organics out and make clean wastewater? Same for fresh water. If you're trying to improve it through a membrane surface or any sort of ion exchange, can you do it more efficiently? So those are, in general and generic terms, the things I'm working on. The thing that's probably caught my eye that I've been working on most excitedly for the last kind of 2 or 3 years is this forever chemicals, or PFAS. Mm-hmm. And so I think this by far will be the legacy problem of the next 50 years. This is kind of like DDT in chromate with Aaron Brockovich in 1990. This problem is huge, And it's much more prevalent than either of those issues. It is everywhere. And unfortunately, if you put 10 drops in Lake Tahoe or Salt Lake City 100 years ago, all 10 drops would still be there. It just does not degrade in any short or long term. So it's ever present. And if it gets into the groundwater or gets into any body of water, it's going to be there forever. And we're showing extremely low toxicity levels that are problematic. So in a typical water treatment world, we talk parts per million, like 1 part per million of chlorine is normal. And kind of, you don't want, chromate, you might have 300 or 400 parts per billion is a problem. So many of these things, 1,4-dioxin is a part per billion issue. This is not part per PFAS. Control regulations are going to be 10 parts per trillion. So that's 1/1,000,000th of a part per million. I mean, it's, it is infinitesimally small. And so the problem is you have to collect it and destroy it. And that's expensive if you have large bodies of water, be it drinking water or leachate or any sort of groundwater. You have to remove this, and it's very expensive.
You kind of hit the perfect persona for this podcast, because you have access and you've worked with technology, you've worked in large corporation management, and then you also had a little stint in Marin with the water board.
Yeah, drinking water, yes.
With kind of what you're seeing with PFAS today, your entire history with Ecolab, and even touching on your experience that you had in policy, where do you think that governments can kind of help here, right? Because we came across this problem because we let PFAS be made and basically let it into the environment. Is there a way to stop the next PFAS through regulation? And then kind of what is regulation doing today to actually fix this issue?
Well, I think PFAS we're going to find is in a lot of stuff. So every pizza box has a lot of PFAS because it helps the box from not getting crusty. All the paper straws we've converted to over the last 5 years because we didn't want plastic straws in are all filled with PFAS, and they still kind of crumble. And, so it's in Teflon, it's in every Patagonia outfit. It's not intentional. I think we've just found through good science and analytical methods that there's these clusters of people that have big problems with cancer and other issues where there's high concentrations of PFAS. So luckily, our environmental protection agencies around the world are starting to understand what clusters mean, and they found that this is the problem. Now, how it got there and how fast we can remediate it, kind of like removing bad hairspray and other carcinogens and things that are bad for our atmosphere, I think it'll go pretty quick. But this is one that the EPA has stepped on. Usually they put out a guidance, they wait 5 years, blah, blah. This one, they just stepped right in front of and said, we are going to prohibit all this in 2026. It's not going to happen. You're not going to allow it in drinking water. You're going to have to notify people. So this has gone to a 5-alarm fire very quickly. And technically they are 110% confirmed that this causes cancer. And if you can get it out of your drinking water, you're going to be a much healthier person.
Yeah. Yeah. In kind of working with the Fred Sense, and, I know that they're working on PFAS as well. We actually had David on the podcast a few episodes ago, so we'll be launching an episode. But my question is kind of more zooming to the 50,000 foot level. If there are entrepreneurs out there working on water technology, since you've just seen the full gamut of a large company like Ecolab buying technology, working with smaller companies like Fred Sense, working on this, what's 1 or 2 rules or 1 or 2 tidbits that you have for entrepreneurs out there? Do you have anything that you've kind of seen in pattern recognition of,
Good question, Robbie. I don't think that there's any one thing. I think to be a good CEO and lead one of these companies, you have to have a lot of skill sets. You have to be very balanced. You got to take care of your people. But in the end, what the investors are looking for, do you understand the market, the problem, and does your widget solve it? And then secondly, can you build a plan for your product to solve this commercially in the market? Can you get traction? Can you get trials and demonstrations? And then is it economical? Will they re-sign? Will they if they try it at 2 sites, will they put it at all 50 sites? And so I think that's the part that most people struggle with, and they kind of just gloss over. Oh yeah, we got this great thing, and look how good it works. But they haven't really spent the time to understand the market. So first off is defining the market needs, and what's the total available market, what's the addressable market, and then secondly, what is this precise method that you are going to do to get to the market? Is it going to be industry reps? Are you going to hire your own sales force? How are they going to get in to see the client? Why would the client want to see them? All these other things that have to go into kind of building the perfect soup.
Yeah. Makes complete sense. We're coming on close to time here towards the end of the episode. There's one question I ask everybody, and it's, is there a favorite book, TV show, or movie that has, changed your outlook on the water world, or even just in your life in general?
That's a good question. I think it's about change. So I've read dozens of books about change. The first one that comes to mind is Who Moved My Cheese, because that was one of my favorites. Mm-hmm. And I think Tom Peters had a lot of good books and strategies early on at Stanford about, just kind of this ability to articulate the issue and be able to sit down with someone and say, I have a solution for you. How do I de-risk this so you get involved and want to try it? So I think the best salespeople to me are the most empathetic people. They immediately know, looking and seeing and feeling the desk, the way the guy that walked in the room, how this person across them likes to be addressed and likes to solve problems. And they quickly sense an ability to adapt and be versatile enough to come up with a way to converse with them and build a mutually agreeable solution. So I think there's a lot of mutualism in good entrepreneurs that are successful, because if you think about Steve Jobs, all he was thinking about, all he was passionate about was coming up with something that was so universally important to each and every person that touched it. And I think it's that passion that the successful entrepreneurs often bring to their new innovations and their widgets.
I love that. Chris, thank you so much for coming on the podcast. For all of those,
I haven't talked so much my whole life, so I feel bad, but it was great being with you, Ravi, and I'm really glad you're exploring these things for all of us and trying to help out the water weenies of the world, as we like to call ourselves.
Yeah, thank you so much.
Thank you.
And for all of those of you out there, if you want to listen to Liquid Assets, you can find us at liquidassets.cc or anywhere else you get your podcasts, or on YouTube today.